Good afternoon, and thank you for joining us for virtual Bulldogs Behind the Scenes, featuring an exclusive tour of the UMD Heikkila Chemistry and Advanced Materials building. My name is Molly Clevin, and I'm from the University of Minnesota Duluth Alumni Relations team. Today, we are going to visit the Heikkila Chemistry and Advanced Materials building located on the UMD campus. Now to introduce our guests. We are fortunate to have Dr. Stephen Berry with us today. Dr. Berry is an associate professor and chair for the Department of Chemistry and Biochemistry at the University of Minnesota Duluth. He graduated from UMD with his undergraduate degree in 1997. He received his PhD from the University of Illinois at Urbana-Champaign in 2003. His research interests include copper proteins, the role of copper in structure-function relationship of enzymes. It is now my pleasure to welcome and hand it over to Dr. Berry.
Good afternoon, everyone. Thank you, Molly, for that introduction. It's certainly my pleasure to be here. I wish a warm greeting to all of our friends of UMD and, of course, our fellow Bulldogs. I know I'm really proud to be an alum of UMD myself, and really excited to be back here working as a faculty member and chair of the Department of Chemistry and Biochemistry. It's certainly an honor and a privilege here to be working with all of the faculty and staff on campus, as well as our students. And I'm excited to have this opportunity. I'd like to thank Matt Duffy and Austin and Molly for inviting me to host this webinar. It's really cool to show off this brand new building, the Heikkila Chemistry and Advanced Materials Science building. Before we actually get for the walking tour, I just wanted to put some stats on some PowerPoint slides here to let you know some of the specifications about the building. First of all, the building, planning for it, started years ago. The architects were BWBR, architectural firm from St. Paul, Minnesota, and they actually started in the design phase in the spring of 2015. And I was associate department chair at that time, so I had the honor and privilege of being able to serve on the committee working with architects to design this building from the get-go. And 2 years later was when the state of Minnesota passed the state bonding bill that included funding for HCAMs. And that was in May of 2017. And we had those blueprints from the architects all ready to go. We broke ground immediately in July of 2017. And you can see there a photo from the groundbreaking, and actually standing next to Champ are Kurt and Beth Heikkila holding the shovels there. And next to Kurt and Beth, also kind of fun facts, other neat people who are here are Jim and Sue Swenson. And then next to Jim and Sue Swenson are Bob and Kathy Carlson. And then next to Bob Carlson is the Dean, Josh Hamilton, who was Dean of the Swenson College at that time. And then, of course, our Chancellor, Lynn Black, and the EVCAA at the time, Andrea Shocker, are all featured in that photo. So the groundbreaking started in July of 2017, and they broke ground and stitched up a frame and foundation for the building, and were able to work through the winter. The construction was organized and carried out by McGough Construction. And for 18 months is all it took them to complete the building. By the end of December in 2018, the building was completed. And Department of Chemistry moved in over that spring of 2019, and we held our grand opening in August of 2019. During the design phase, moving on to the next slide, we kept some design themes always at the forefront. Every time we had a architectural committee meeting, we always talked about how we wanted this to be, of course, a state-of-the-art chemistry materials research building, as well as supporting education of chemistry and materials students. We also noted that the old chemistry building lasted 70 years, and in fact is still going strong. But that was one of our goals, was to use the best quality materials, was to be really intentional, excuse me, about making the building functional and adaptable, so that this building would be here 70 plus years to come as well. So we're really proud of our work in designing the building, thinking of its longevity. And then, of course, sustainability is a goal of UMD campus and a goal of ours, that every detail was thought of about efficient electrical usage, the way heat in the air was, we didn't lose heat out of fume hoods, so there's sophisticated heat exchangers, and of course the air is filtered, so it's clean air in the building. The water is used very efficiently, excuse me, both inside the building and also with the way stormwater is processed. We're very aware of that. And of course, the lighting and materials that we use, we wanted to source locally any way we could and use best quality or renewable materials. And of course, we always have the nature and the fact that UMD is located in northern Minnesota and the land of 10,000 lakes. We wanted to use not only water efficiently, but also have plants and native plants around the building, and use glass on the material that have low strike events for birds. And then the last design theme, there are probably others as well, but the last key one was we talked about this idea of science on display. We wanted students and visitors to the building to be able to see into labs and see research. And we wanted to be able to have visitors see into the instructional labs and be able to see students learning. And we, on purpose, constructed what we called science neighborhoods, where we have research labs adjacent to instructional labs that are adjacent to faculty offices. And so we have these different neighborhoods that are on purpose juxtaposed next to each other, so that we have this intentional interaction of learning and research and faculty and staff and students together. And then the last slide here just is some of the statistics of the building. It was a $45 million project. $30 million came from that state bonding bill, and another $15 million came from you all donors of UMD, as well as UMD itself. And the building itself is 56,000 square feet. It has the Department of Chemistry and Biochemistry main office, as well as the Advanced Materials Center main office. It has 12 research labs with the Advanced Materials Lab that's part of the EMC. And then there's a shared research instrumentation lab with some materials characterization and chemistry instrumentation. It also has instructional labs. There's 5 instructional labs, 3 conference small classrooms that we'll see today. And there's 5 kind of common areas where students can study and hang out. And then we have office space for at least 22 faculty and staff offices, separate offices, and then there's graduate student offices, workrooms, so some large areas there that we'll get to see on our tour today. So with that, why don't we begin our tour then? We'll start entering campus here out from College Street. As you drive up 21st Avenue and Woodland Avenue and turn onto College Street, we were really aware of the fact that this new HCAMS building would be one of the first buildings that you would see as you enter campus from College Street and drive up University Avenue here. And so, of course, we wanted to make the HCAMS building very visually appealing, have it be a very welcoming presence as people park in that parking lot. And a lot of, as you may remember, most of the campus is connected through corridors, the entire UMD campus. We wanted this to be a very welcoming building. And here, as you drive up University Avenue, you can see there's the address plaque for the building announcing the Heikkila CAMS building. And one thing I wanted to highlight at this point before we go inside is that, again, this is sustainability was one of our key design themes. And we went along with Minnesota B3 energy certification. LEED certification is another common one, but Minnesota B3 was designed by University of Minnesota engineers and is specific to northern Minnesota climates where there's more heating days than cooling days. And so this is an energy certified building that's Minnesota B3 certified. And we wanted to use sustainable materials. Those are iron spot bricks that you see, the beautiful red and brown bricks. We have aluminum window frames, tin siding. We use concrete. That's a native basalt rock that you see kind of decorating the landscape just around the immediate exterior of the building there. And then a lot of like native trees and native plants were intentionally planted around the building. A lot of studies show that having greenery around a building makes it a more satisfying place to work and certainly to study for our students as well. So sustainability was a big factor. And then as we continue here around this side of the building, this north face of the building, you can see that skywalk in the distance that connects HCAMS to the entrance into campus. It happens to connect into the medical school. And here's a view now walking further, looking from the Darlin side, walking further down the street, you can see the skywalk and it connects into the medical school. And fun fact, this is the longest unsupported span on the UMD campus, this connection here between these two buildings. But that span is high enough that we can drive a semi-trailer truck underneath it if we have to. In fact, underneath it is a loading dock to the medical school where we receive chemicals, kind of a loading dock there. But the location of the building and its connectivity to the UMD campus was a really important thing that we talked about during the design phase as well, because we wanted to keep in that theme that all these buildings on the UMD campus are connected. It makes it an enjoyable place for everyone to work and for students to study, to be able to walk around campus in the winter and have everything be indoors. So As we continue with our tour here, now we'll continue around the south face of the building. This is kind of on the Lake Superior side of the building, and you can see here some more beautiful green spaces. These are like irrigated by water drip irrigation. Also, they serve as stormwater basins that runoff from the roof of the building is collected there and filtered and is cooled also before it goes into the groundwater. That's a really important factor. There's some native trout streams in the area. We wanted to, instead of having water running off hot pavement and warming up, we wanted to cool the water. And so this is a common design theme in a lot of energy certified buildings, is to have cooled and filtered water. Here, continuing around the south face of the building, is this courtyard or plaza area to HCAMS. That is one of the first areas that you'd walk into after parking your car out here in the parking lot. And you can see again all of the greenery. We planted native plants here and perennials and trees. And you'll also notice all of the seating. We wanted to design this area to be welcoming to students and staff and faculty to be able to sit and grab lunch at the lunch hour. Or we also have had picnics here during our summer undergraduate research program. We'll host barbecues, and we designed this space to be a location where we could have a departmental barbecue, and we've had a number of them here already, even in the couple of years that the building's been open. Here in the courtyard also, it features one of the two art pieces that were commissioned for this building. This is called Polytropos, and it was designed by artist Maria Artemis. And Maria Artemis is an artist from the Atlanta, Georgia area. She met with faculty in materials and chemistry years before the building was constructed, and was inspired by materials and designed this. It's a funnel, a spider funnel web with dew on it was her impression. But polytropos means many forms or adaptive forms. And that was what struck her in talking with chemists and engineers about materials, is how they have maybe a similar molecular makeup, but they can be used in so many adaptive ways to suit different purposes in our modern life. And so that's a beautiful view of polytropos. It's illuminated in the evening. It's quite nice. And also there's native rock around the floor of it that's from the Virginia area that was inspiring to Maria, because a lot of the materials that we use here in northern Minnesota come out of the ground here in the area. Here's more water filtration that's here in this plaza area. The water runoff from the roof of the building also runs through these channels and is collected and filtered and enters into the ground where it's cooled. You can see more of that native basalt. And then here's another view of the side of the building with the bricks. And it's really a treat. Every day the brick takes on a different color. And I think this day that we're out here, you can see this view. It's a beautiful brown red brick. But when we pan over, you can see the really tall windows here that illuminate the building in the interior. But there's some of the tin shingles. Oh, there you can see the bricks in the distance now take on a metallic hue from this angle. So this is the same red brick that was on the other face, but in different light, it's red. And here's the entrance of the building. Kind of looking up, it's an impressive 3 stories high, 4 stories if you include the penthouse at the top. And then here's the name of the building right at the entry, the Heikkila Chemistry and Advanced Materials Science Building. And I wanted to take a few minutes and thank the Heikkila family. Kurt and Beth Heikkila donated money to help build the building. And Kurt Heikkila is a 1979 graduate of the department. He received a master's degree here, and I think he worked with Tom Beidelek in analytical chemistry. But Kurt and Beth went on to found Tundra company. That's a White Bear Lake, Minnesota-based company, and they work in materials. They take on a number of many different projects, but I characterize their work as being involved in composites, and they modify materials to bring materials together to take on new functions. And so we really appreciate their support of the building. And in fact, they just were here to visit just a month ago. So it was great to have them continue to stay engaged with the students and faculty of the department. So as we enter the building, we first here see a student study area with a beautiful view out into the plaza. It's just really bright, and there's so much natural lighting that comes into the building because of all the windows. And then right next to the student study area is the Advanced Materials Center office, where Michael Plummer is the current director of the EMC, and he has his office in there with the staff. And they are working with local businesses and seeking collaborations and research projects to work on. Here's the Advanced Materials Lab, where proprietary research is going on. I actually don't have a key to that space because of the kind of potential patentable nature of the work that goes on in there. But that's where the magic happens with regards to some of the advanced materials in this building, in addition to the colleagues in the chemistry department. Just behind this materials lab is some neat display cases. We actually have a time capsule that was dedicated with the grand opening celebration of the building. That time capsule was dedicated in 2019 and will be opened in 50 years in 2069. So watch for your invitation to that event. Here, right across the hallway, is another wonderful display case with just some neat things. There's some awards that our chemistry and biochemistry club have received in the University of Minnesota system this last year. Also above, we have a very neat timeline that was something we had as part of the grand opening, starting all the way over. I apologize, you can't see the details, but in 1895 is when UMD opened. It was called Duluth Normal School at that time, and it wasn't renamed UMD until 1947. But in 1949 is when the old chemistry building was constructed. And so that was 1949. 70 years later is when HCAMS opened and became the new home of the chemistry and biochemistry department. And so that timeline kind of features those different key dates of when buildings were built and such. Also in this display case, if you look in the lower left-hand corner, I wanted to say a few words about those old notebooks that are there. Those were donated by Nathan and Elaine Ballou, who also donated money to support the research instrumentation lab in this building. But Nathan Ballou is a 1941 graduate of UMD, and he received his chemistry degree here. And remarkably, he went on to work on the Manhattan Project as a graduate student. He went to the University of Chicago in Illinois, and one of those notebooks down there in the corner is his recently declassified graduate thesis, where he was working on nuclear chemistry and the Manhattan Project. Also, some of those notebooks are from when he was a student here. One of them is his 1939 organic chemistry lab notebook, and in it, it's amazing the experiments that students did in those days. He ate sodium benzoate the day before lab. He collected his urine overnight, and then in lab the next day, he purified uric acid out of his urine. So it was an organic chemistry experiment. And so it's just fascinating to read those notebooks, because we, of course, could never do those types of things today. But some really interesting reading. I really appreciate those artifacts that were donated by the Ballou family to our department, and proudly display those in the display case there. On the opposite side of the hallway here is some other very neat glass plaques that were dedicated with the grand opening of the building. We have on the left side the plaque that's signed by Kurt and Beth Heikkila with their kind words and dedication to UMD and our students. In the middle are the state senators and representatives, our regional representatives that supported HCAM's building and helped us to maintain funding or obtain funding for the building. And then on the right-hand plaque are friends and alums of UMD who donated money to make HCAMS a reality. Right behind that wall is one of our conference rooms where we have department meetings, graduate student seminars. We also teach classes in there. There's a kitchenette for informal luncheons and things. And then here we're entering the Department of Chemistry and Biochemistry office, where we have staff members who work, and the department chair's office is in there as well. And then as we leave the chemistry office and move across the hall, here is our what we call the Nathan and Elaine Ballou Shared Research Instrumentation Lab. And here we have most of the really large research instruments for the Department of Chemistry and Biochemistry, as well as the Advanced Materials Science Center. And I mentioned Nathan and Elaine Ballou also donated those fun artifacts for when Nathan was a student here. But inside this research instrumentation lab, we have, I didn't get a chance to add it all up, but over $1 million of research instrumentation. This was obtained from support from donors, but a lot of it was also from grant money from faculty that wrote grants to the National Science Foundation and other granting sources. And as we enter the lab, this facility was designed to be flexible and adapt to new instrumentation. There against the wall is a very large air conditioning unit that keeps humidity and temperature of this room to very strict standards so that these instruments can function properly. And there's a $400,000 liquid chromatography mass spectrometer. There's a gas chromatography mass spec. Here, I apologize for the mess on that table, but we're actually installing some material science characterization equipment there against the window. And here in the back corner actually is a student in the material science program who's using infrared spectrophotometer. And right around the corner here is our 400 megahertz Bruker nuclear magnetic resonance spectrometer that is liquid helium cooled to keep the superconducting coils at 4 degrees Kelvin. And this is a very efficient, low helium use NMR that we're really proud to obtain as part of the new HCAMS building. And actually, when we're in here recording, it just so happened, I think you'll see it here, that a sample that students were running were changing. So you can see a new NMR sample here being drawn up by the auto sampling device, and it enters into the belly of the instrument there, where it's put in a high magnetic field, and that separates environments of protons that are in carbon-based compounds. And so the chemist can tell structures of molecules by looking at the NMR spectrum. Here also in this room, is our EPR spectrometer. That tiny white and green box is a benchtop model. It has all the resolution of a full-size EPR, however. Here's another air conditioning unit in this building. And every tour of the building, we spend some time talking about what's above us. That above us is another 8 feet above the ceiling of heat exchangers and air exchangers and ductwork and electrical piping, so we can support 220 volt or 110 volt, whatever we need for different instruments. A lot of adaptability was designed up above in the ceiling. Here's another fun, I'll call it a toy, but it's a research instrument. This is another proton NMR. This is a benchtop model. Some of you who studied chemistry here may have taken NMR on the old 100 megahertz NMR that was about the size of a washing machine. Here is its replacement for students, that it's a smaller 70 megahertz model that has all the resolution of that old 100 megahertz model. Every lab has whiteboards. You can see this one's been used heavily by students that are analyzing data and planning their next samples. So as we leave the research instrumentation lab there on the first floor, we'll walk down the hallway. There's nothing wrong with the restrooms. If you see that blue tape, they're just the floors were being waxed on this day. But here's 2 research labs now on the Lake Superior side of the building. We'll enter into 2 of our analytical chemists lab. Here's Professor Luke Busta's lab, and adjacent to his is Professor Maurer Jones's lab. And as we enter Professor Busta's lab, he actually has quite a large summer research group this summer with undergraduates and graduate students. And you'll be able to see his research space here. He's talking with some of his graduate students there, obviously. And we got to meet some of these students during our tour here. You'll hear shortly from a graduate student, Dean Min, who will talk about his research. And Professor Busta will tell us about what he does also.
Well, so my name is Dean, and I'm a graduate student from Dr. Lucas Busta's group. And the project that I'm currently working on is called Chemical Bloom Project, which is essentially, I'm studying about a kind of compound called triterpenoid, which has like 5 rings, and it can be found in a lot of plant species. So we are working with a lot of citizen scientists like around the US, and they send us like all the sample on cotton swab like this. So I extract those sample like around here using chloroform, and I put it on this small little vial.
All right, my name is Luke Busta. I'm a new assistant professor in the Department of Chemistry, and we're working on the chemistry of plants. And at the moment, we're working on the surface chemistry of these really interesting plants called kalanchoe. I don't know if you can see, but they have this funny white coating on the outside of the plant. And this white coating is actually really unique to some desert plants, and it helps them survive in conditions where there's very little water. And so we're trying to understand the chemistry of these particular desert plants and how we can transfer that chemistry to our crops so that we can have crops that survive in hot, dry growing conditions. And we're using the facilities in the new HCAMS building here to do that. And we have several things that really help us do that. I think you have seen or will see some of the new instrumentation that we're using, but we also have these really nice modular lab spaces where we can move tables around so that students can work together. And there's sort of an open lab concept that we quite like, so that we can sort of have different people from different bench areas working together as well. And this is important because these people in these different areas have different areas of expertise. So we have some biologists here in the lab, there's some biochemists, there are some analytical chemists, And because of the space that we have, they can all work together to try and solve these complex problems to help us make, in this case, to make agriculture more sustainable. And so we're grateful that the building gives us the opportunity to do that.
Yeah, so thank you, Professor Busta and Dean. And right adjacent or part of Professor Busta's lab is Dr. Mara Jones's lab, and she studies the degradations of plastics in the environment, kind of from an environmental perspective, but also from the perspective of designing better plastics. And she's actually supported by the National Science Foundation with a very large research grant right now, over $600,000 to study this phenomenon. And she's acquired a number of state-of-the-art research-grade instrumentation. There's a differential scanning calorimeter, and behind it that we'll see here is a thermogravimetrics analysis instrument for analyzing materials. And Dr. Mara Jones is collaborating with a number of our materials colleagues and chemistry colleagues and acquiring a lot of these materials instruments and is assembling these to create a materials characterization lab on our campus. And right now they're housed in her research lab where she uses them primarily with her students. And here's another view more, excuse me, down the lab here of Dr. Mara Jones's lab. Here's a student working at a benchtop. And again, you can just see how beautifully well lit these spaces are. If you look outside, it's quite bright with the sun there. You can see how just convenient the bench space is there with shelving and drawers that are easily accessible to students. And so it's just a real treat to work in this building. As we now exit the first floor, we'll go up to the second floor and we'll be introduced to some inorganic chemistry students that are doing inorganic chemistry research. This is Professor Prashant Padatori's lab. And there's one of the students, Noah Holzer, who we'll hear from shortly. We cornered him and asked him about his work. We'll hear from him shortly. But you can see, again, this beautiful large research lab. There are alcove spaces for specialized instrumentation. There's graduate student Brandon Bayard and an undergraduate, Seda Owe, who's doing research on a project this summer. And there's Noah's samples. So Noah, tell us about your work.
Hello, I'm Noah Holzer. I just graduated my chemistry BS and I'm going into a material science master's degree now. I've been working in this lab, the Padatori Research Lab, for the last 3 years, and our research actually encompasses a lot of different photochemistry. Our main research is focused on the design, synthesis, and characterization of a whole wide variety of photoactive dye compounds for use in really 3 main areas. First of all, artificial photosynthetic solar panel creation. Secondly would be creating drugs for photodynamic cancer therapy. And third would be creating molecular machines that are activated by light. And honestly, what I've liked about moving into this building is I think I've got a lot more productive since moving into here, because really we have everything set up in the fume hoods that we could possibly need, and the new space is just wonderful.
Thank you, Noah. And then we'll exit that lab and just go back, continue down the hallway here. And I'd like you to meet one of our faculty who specializes in the research of chemical education, that he works with our students and faculty to study different chemistry education methods and to assess the outcomes of those. So we'll hear from Dr. Wayman and one of his summer research students, Tanner.
All right, my name is Jake Wayman. My research group studies chemical education research here at UMD in this space in the building. We primarily focus on trying to measure the effectiveness of faculty, myself included, and other faculty in the department, and how implementation of different modern teaching styles in their classes to see if that implementation is actually effective or not. So we do a lot of work with looking at students' grades, measuring their learning in different ways that are maybe different from exams, or even just looking at final scores at the end of the semester to see how different ways of teaching help adults learn chemistry. And we also really look for evidence to see if different methods are effective in different ways for different groups of people. So are the ways that we're teaching equitable for men and women, for white students versus students of color? So we spend a lot of time looking in these data to see if we can get a better idea of how to best teach chemistry to all of our students.
I'm Tanner Swenson. I'm a student that is participating in the UMD's CERP program, so Summer Undergraduate Research. I'm working in Dr. Wayman's lab doing qualitative analysis on a survey that was given to Gen Chem 2 students, asking about their beliefs of advantages or disadvantages for traditional versus a flipped classroom.
Very cool. Thanks, Tanner and Professor Wainman. So we've now exited the second floor, and I'll show you around the third floor. Right up here, as you reach the top of the stairs, is another student study area. This student study area is largely undiscovered by students yet. It's hidden up here on the third floor, but it's a beautiful space. Again, you can see all the green trees and the well-lit environment here that just makes it a cheerful place for students to study and to collaborate together. Right here, adjacent to the study area, is a look into some more research lab space. This is Professor Victor Zhedonkin's lab space. He studies iodine as an environmentally friendly oxidant for synthesis of drugs or any kind of organic synthesis applications. But this research lab is part of one of these open labs that if we'll get a view here shortly, all the way down the entire floor of the HCAMS building. And this is not all Professor Zhedonkin's space. It actually is 4 and actually now 5 faculty research spaces that share benches and perform research up on the third floor of the building here. And you can see the fume hoods, how they have glass backs. You can see through them. It's beautifully well lit. Moving back out into the hallway, I talked about that theme of science on display. You can see how from the hallway, we can see here into a graduate student study space. And then that window in the back is a view into the research lab. We can see through fume hoods and actually out the window. So a lot of natural light just makes this a cheerful building to work in, to study in. Right across the hallway from those research labs are some upper level, like senior level instructional labs. This is our inorganic chemistry lab space. I teach an inorganic chemistry lab in this space. Right now, I apologize for the clutter. There's boxes all around with some equipment and chemicals. This is a faculty actually are preparing some take-home lab kits, developing some online lab curriculum for our entry-level general chemistry class. And this was all due to COVID and some of our adaptations to flip classes online because of COVID. And so that's our online lab take-home kits. As we leave the inorganic lab, it's juxtaposed adjacent to an instrumentation lab where students learn how to use state-of-the-art chemistry instruments. And we have over a dozen research grade, honestly, instruments in this lab, but students use them. And this lab houses inorganic chemistry instruments as well as physical chemistry lab. And we teach a lab called instrumental analysis in this class. And all of our seniors touch all of these instruments. In the summer, these instruments are used for research. You can see one of our faculty, Bryant Goody, there in the back, who's actually doing some collaborative work with a local brewery, studying alcohol content in some of their creations. But there's an MCD spectrometer, all kinds of nice toys in this space. But students get to touch these instruments. They conduct an experiment, usually in pairs, during their lab period. And then they move into this other adjacent room that we're really proud of. That's a kind of a computer room, presentation room, where after students have conducted the experiment, they then move into this adjacent room that we'll enter here shortly. Here it is, where students can analyze their data on those computers. We have chemistry software on those computers for students to use. And then they can give a presentation to the course instructor and the teaching assistant and their classmates in the space. We also keep this space open during the week for students just to come in and study or work together. Moving back out into the hallway, a feature on all the floors of the building are these red writable walls. Actually, the full-length red wall, and you can write on them using markers. And we have markers in the chemistry office students check out. And during the semester, these walls are filled with chemical structures and biochemical pathways or whatever students are studying that week. So they're quite fun. Also, these walls are magnetic, and so you can see a poster there that's held up by those wooden magnets. And we have poster sessions up here to welcome our graduate students, or chemistry club web poster sessions on these floors. So here's, again, walking down the hallway, you can see the red walls on the right, and research labs would be on the left. So again, we've kind of juxtaposed the research labs on one side of the building, opposite the instructional labs on purpose for the mingling of students and researchers. And here's another look through the windows all the way outside. Again, a lot of natural lighting. Another look into a graduate student space, and look at how bright the sun comes right into this windowed area here. Here's another one of the conference rooms that's on the third floor. We have student office hours in there. We have small classes that we teach in there. And then back in here is what some of the faculty office space looks like. There's one of these on each floor, and there's space for 7 faculty offices back here. And of course, students would come back here to meet faculty for office hours or study on that red bench there, for example. And so that's juxtaposed right next to the instructional labs. There's mailboxes for dropping off homeworks for teaching assistants or faculty. And then out here is another one of the wonderful student study areas that's so well lit. This study space, we appreciate Bob and Kathy Carlson for donating money to name this space. But this has, again, more beautiful views. Actually, you can see Lake Superior from up here on the third floor and all the natural trees and greenery. And this is a wonderful place to study in the winter. The sunlight shines in here and it's warm and very cheerful on a cold winter day. You can see Lake Superior in the distance. And this picture doesn't do it justice, but this is high up. We're on the third floor here. And those of us with fear of heights, a little bit of jitters up here, those are full length mirrors that go all the way down to the floor. So it can feel a little scary and perched high up here on the third floor. But no, it's a wonderful place to study. And so that's the third floor. And again, a lot of the spaces are similar on the second and first floor. But now we'll go back down to the second floor and we'll walk you out of the building. There's through the Skywalk. And as we enter the Skywalk area here, part of the building, here's our second piece of artwork that was commissioned for the building. This is called Molecule. These stained glass art pieces that were created by artist Paul Hausberg, who lives and works in Rhode Island. And these are immense stained glass windows. These are 10.5 feet tall and over 2 feet wide. And Paul actually had to travel. I had the pleasure of meeting both of the artists. They were here for the installation of both of their art pieces. They cared so passionately about these projects. But Paul had to work in a special German glass facility to fabricate those stained glass windows. But they bring a lot of bright and cheerful energy to that space. And so now we leave the HCAMS building and enter into the Skywalk. Again, the largest kind of unsupported span on the UMD campus. But even this is a beautiful, well-lit place to walk through. And you can see a view here now back down University Avenue to College Street. And there's where we started our tour at the end of the street there. And this is a view of HCAMS from the north face here. Again, you can see those tall windows that illuminate the building. And it's that same red brick, but here it takes on a gray color, just beautiful different shades of colors that it takes on depending on the lighting. But this photo is of the roof of HCAMS, where we have, again, it's an energy certified building, Minnesota B3 certified, and it has 50 kilowatts of solar panels up there that you can't see. They're laying flat on the roof. And also, of course, up there in the penthouse areas where all of the sophisticated heat exchangers and air filtration systems are found, a lot of the air conditioners. So that's a pretty impressive feature of the building, is all of the cutting edge air handling and filtration systems. So then that concludes our tour. We're walking out of the Skywalk here and into the medical school and on to the rest of campus. So I hope everyone enjoyed the tour. I'd be happy to try to answer any questions that you might have now. And thank you for this chance to give you a quick tour of HCAMS.
Well, thank you, Dr. Berry, for taking us along on that tour. We are now going to transition to our live question and answer portion of the webinar. So Dr. Berry and I are going to turn our videos on. And as a reminder, you feel free to use the question and answer button on the bottom of the screen, and we will get started here. Perfect.
Yeah, great.
Well, I think our first question asks, could you just describe what advanced materials are?
So advanced materials, that's a great question. And even different disciplines of chemistry would give you a different answer. Organic chemists, for example, in the state of Minnesota, we're known for the company 3M that's involved in making plastic polymers, and that's an advanced material. I think a big theme here on the UMD campus is that of composites, where you're taking different kinds of existing materials and mixing them together to take on new properties. Like I know, for example, I think of the Heikkilas that are involved with some of their materials. They're interested in taking recycled wood fibers and putting a coating on that so it can be encased in a plastic. So it kind of takes on all new kinds of properties. And so that's called the field of composites. And I know a number of our engineers here on the UMD campus are interested in creating different types of concretes that have different structural aspects. And they're interested in taking recycled glass and mixing that with the concrete and creating a new kind of composite material. And so I think to answer your question kind of from the UMD-centric point of view, I'd say composites is maybe a big theme here on our campus, is mixing together different materials, because it's harder than you might think to combine two different materials and have them bind structurally in a structurally sound way. But that's a big piece. And part of the advanced materials science And an AMC office, part of their mission here is to support our advanced materials science graduate program. That's a brand new program that just started 2 years ago, and it's been a really popular program. But students in that program have chemistry backgrounds or engineering backgrounds, and to bring those two fields together is something that's needed in the engineering and materials field. The chemistry field is to have engineers and scientists, chemists talking together. So that's one of the missions of our program. Yeah.
Well, and then kind of a follow-up to that question, what types of degrees would students use or have in a building like this?
So that's a great question. So this building supports the Department of Chemistry and Biochemistry. And so those instructional labs that we saw on the third floor, all of our chemistry and biochemistry majors go through classes in those lab spaces. And so it's certainly chemistry and biochemistry majors, but also anyone that's taking one of those chemistry labs, like a number of biology majors, minor in chemistry. We also have an environmental science degree on campus. And so environmental scientists are in this building taking classes, as well as I mentioned, biology majors that are minoring in chemistry. And then, of course, there's a number of graduate programs that are doing research in the building or having classes taught in the building, like the Advanced Materials Science graduate program. We have a chemistry graduate program. Chemistry MS degree, and this building supports that. And then there's a number of graduate programs in the engineering departments in the Swenson College that would use the research instrumentation here or take classes that are taught in the conference rooms that we got to see today.
Perfect.
Yeah.
We just had a question come in wondering if there is an area devoted to electrochemistry.
Oh, that's a great question. Let me think about this. Right now, we don't have a professor whose area of expertise is in electrochemistry. I know one of our emeritus professors, Professor John Evans, who just retired a few years ago, was an expert in electrochemistry, and he had a pretty sophisticated research setup. But right now, I think a lot of us, like myself included, have potentiostats and do electrochemistry as part of the characterization of our compounds. And so we use it as a tool. We're not necessarily experts in electrochemistry, but to answer your question, yes and no. Yes, we definitely have electrochemistry setups in all of the labs, including the instructional labs. In fact, there were some potentiostats in that large instrumentation lab. The student lab that we saw back in the corner is one of our potentiostats that students use. But currently our analytical chemists specialize in other fields besides the electrochemistry. Yep.
So you had talked about and showed us some of those boxes that were being shipped out to students. So we did have a question wondering, how does virtual learning work within the teaching and chemistry of chemistry and advanced materials?
Yeah, I mean, that's a great question. So it's very challenging. Students require hands-on, be able to touch and feel chemistry. But with COVID, we were forced to try to do something. And my colleagues were very creative in coming up with this lab kit idea. And these lab kits were focused just at the low-level general chemistry level. And actually, they're created really brilliantly. Our lab fee is $80. These kits cost $76, including shipping. So I really appreciate my colleagues who designed these. But it includes some chemicals and equipment where students can conduct a dozen labs at home on their own, just in this box. And then what's even more brilliant about this is that students save the equipment. And then if they take general chemistry 2, we ship them a second smaller box that just has the chemicals for the general chemistry 2 labs. And so these are, but that might be fair to call this kind of a research area too. Some of my colleagues are studying like kind of the best way to make these kits and send them to students. And I would say, our education here at UMD, we're focused on hands-on experience for students. And so this isn't something that we're going to be having all of our majors do in the future, but there is a niche in the world and in the United States for online learning. So some of our faculty are dabbling in this, and COVID forced us to engage with online learning in new ways. And so it ties to material science just in the sense that a lot of our chemistry majors would continue on after general chemistry and go to material science. But right now, there's no material science labs exactly that are being mailed. It's only our general chemistry labs. Did I get the question? I think that's I covered a lot of it.
Yeah.
So, okay.
Perfect. Well, we've seen a lot of the new building, but we did have some questions come in about the old building. So the first one, I guess, just came in is wondering, about the use of the large lecture halls in the old chemistry building for general chemistry courses. Is that still being utilized?
Yes. Yeah. Like Chem 200 is still there. It still seats 395. It's the largest lecture hall on campus. And Chem 200 is still there, as well as Chem 150 and Chem 155. And right now, the old chemistry building, and as the administration says, it still has good bones. It's still a great solid building. It just doesn't have the ability to add ductwork for modern building standards for restrooms and air filtration and things like that. And so it can't support research the way it used to. So it's being renovated right now. There's actually a part of the bonding bill, I think this coming year, is to have money to completely renovate it. But right now it's being, what's the word? The asbestos is being taken. So abatement, the asbestos is being taken out of it. There's just floor tiles and some of the pipe insulation. And so it's being abated right now in preparation for these renovations. And it will be used for office space for researchers that don't require fume hoods, for example, like some engineering or computer science, or maybe some of the math professors might be able to use it for office or research space. And I think last I heard, potentially computer science might move into it, but of course, until it's fully renovated, none of us will really know exactly how it's used. And we still actually have some chemistry space there. We still have NMR in the basement, 500 megahertz NMR. We still have some chemical storage and old chemistry. And one of our faculty members, Professor Venkatram, is doing some organic chemistry in the first floor of that building as well. So it's still being used by some chemistry faculty and some renovated spaces there. So it'll still be used. It'll still be an active part of campus. It's just awaiting renovations.
Perfect. So you had mentioned in the beginning too, this whole idea of science on display. Could you talk a little bit more about that and how this new style and design of the building is kind of at the forefront of for these chemistry labs?
Yeah, that's a great question. Again, it's something that was kind of an exciting revelation for us as a design team many years ago, that usually the way buildings are, and a lot of you may have experienced this when you travel around, you separate the research and you put it under lock and key so no one can get in there except the privileged few that have access to the research lab. And we wanted to kind of go an opposite direction and intentionally expose a freshman level chemist who might be entering on campus, and have them walk right by a research lab and be able to see in and see that this is really an approachable career option or an approachable experience that they can have. So they can see in the research lab. And so it kind of demystifies it a little bit, where they can just see that, hey, it's just someone like me that's in the research lab doing research, and maybe I should get involved. And then they have more opportunity to be involved because their lab that they're taking, as a entry level chemistry major or biochem major or biology major, whatever, in the space is right across the hall from a research lab. So there's opportunity for this interaction and conversations to happen in the hallway. And then right next to that is the science neighborhood of faculty offices, where students also are going to faculty offices for office hours or ask questions. And so they are forced to walk by research labs on one side and instructional labs on the other. And so that's part of the science on display. But then, of course, the other part of it is just the ability to see with our eyes. So there's all the open sight lines, the glass doors. They're not hard wooden doors, but they have glass, full-length glass doors that you can see through. And we saw the windows into graduate student offices. They're not a closed private office, but you can see into there and then into the research lab. Excuse me. And then the other neat piece was I didn't get a chance to really emphasize that, but in the research spaces, all of the fume hoods have glass sides and glass backing. So you can see through them. It is a safety feature, but it also just opens up the lab and makes it so much more of kind of relaxed. What's the opposite of claustrophobia? Like non-claustrophobic environment to work in. It's just really comfortable. And it's the building is honestly naturally lit so well that many of us, this is an energy certified building, and lights turn off if there's no motion in the room. And a lot of us don't even turn the lights on because of the natural lighting that comes in. So it's a wonderful place to be in to work.
So this idea of collaboration, do CAM students ever collaborate with chemical engineering students on campus?
Yes. Yep. The HCAMS supports any kind of material science research and chemistry research. And so this advanced material science graduate program has students from all of these different disciplines, from chemical engineering majors, the chemistry majors, even some civil engineering majors, and other engineering programs are involved in research. That research takes place in the HCAMS building. And then, of course, I didn't mention chemical engineering majors, but of course, they take these upper level chemistry labs and chemistry labs that are in HCAMS as well. So yeah, I neglected to mention the chemical engineers, but of course, they're taking through physical chemistry a lot of times and taking classes in HCAMS. So this building supports not just chemistry, but of course, all of these Swenson College majors that have any kind of interest in materials. Like I say, the material science program has been really popular. It hasn't been difficult to get a healthy cohort of 10 to 12 students each year entering the program, which exceeded expectations. When you first start a program, you only expect a few applications, but right away, I know Professor Bob Carlson and the current director, Michael Plummer, have done an outstanding job recruiting students and generating a lot of excitement about the advanced material science program that is housed in the building as well.
And we just had a question come in wondering about community outreach. Do you have plans to bring in high school students for tours?
Oh, yeah, that's a great question. I actually have a couple of colleagues that are doing summer undergraduate research with high school students in the area, but that's not exactly what the question was about. Our main form of outreach is through our chemistry club. Our chemistry club is quite active in the year, traveling throughout the academic year, traveling to local elementary schools, or even now we are targeting high schools because those are students that would be most interested in our forefront of their brain, thinking about where they go to college. So we're kind of putting more of our outreach aimed at high school age students, but right now our chemistry club does outreach by traveling out to different locations to do science demonstrations and talk about UMD. We do have one science show in the spring semester, usually in April, where the Chem and Biochem Club puts on a science demonstration show and invites the community to come to campus. We have not yet formally included an HCAMS tour as part of that, but of course, whenever prospective students visit the UMD campus, the HCAMS tour is part of that. In fact, I just had an email in my inbox here half an hour ago from a prospective student that wants to see HCAMS and see the spaces. So we're always giving families one-on-one tours through HCAMS, but we haven't formalized it to the point where we have bus loads of students coming to visit the building yet, but that's a wonderful idea. So, yeah.
Well, and I think our last question is a personal question. What is your favorite part of HCAMS?
Oh, wow, that's a tough question. I think my favorite part of HCAMS is sometimes in the winter, I feel like I have seasonal affective disorder, and I love studying and just reading. I bring a paper up there and read in those second, third floor student study areas where honestly the sun is shining in on those cold winter days and it's bright and warm, and it is really a cheerful place to kind of offset the seasonal affective disorder with those short, dark days. But so I think I agree with the students. In fact, those student study areas, we had, it was kind of funny. We would joke about it. We had students even before the building was open, just finding their way into the building and studying up in those student study areas. They weren't supposed to be in the building yet, but they already were in there studying. And so they're quite popular. And that honestly, I guess, is my favorite place to go and read a paper or grade some quizzes or something. So, but I have to say, I enjoy my office. I enjoy teaching in that inorganic chemistry lab too. It's just so large and spacious. And has such great whiteboard and projector for teaching. Instruments are great. So, but just for kicking back with a cup of coffee and reading, I enjoy hanging out in those study areas. So, nope.
Nothing wrong with that.
Nope. Yep.
Well, thank you so much, Dr. Berry, for taking the opportunity to take us on a tour. There's obviously a variety of programs that are housed within HCAMS, and the new technology and science on display is definitely something to celebrate. And so just wanted to thank you for that. If there were other questions that weren't answered today, on this next slide here, there's some contact information for Dr. Berry in our office. So feel free to reach out to either or, and we will try to get a response back to you. Also, if you're new to Bulldogs Behind the Scenes, we average about 1 to 2 of these per month. And so if you would like to be added to our email list, if you're not on it already, feel free to email us at alumni@d.umn.edu. So with that, a big thanks to Dr. Berry.
Thank you. Yeah, thanks everyone.
We hope that you'll join us again. Thank you.